All right, so if you're proving this as an identity, if you're trying to say, I'm going to prove to you that these are indeed equal, again, what you're going to want to do is transform one of the sides to make it look exactly like the other one. And if you're deciding what you're going to do here, okay, the more complicated side has more terms. There's an actual operation that we can perform, so you're going to want to start with the right side here. And it's pretty easy to say, hey, you know what, these two binomials here are multiplied together. Let's expand them out and see what happens. And if you notice, you should notice this is going to end up to be a difference of squares, right? So again, in your communication, please write in words or a show like this with arrows or something that you're going to be, multiplying these out. So you write multiply, or you show the arrows or something so that I know what you're doing. Okay, so then you have 1 times 1, then you have plus cos theta minus cos theta, and then minus cos squared theta. You simplify that, that's 1 minus cos squared theta. Because this is part of an identity, you know that 1 minus cos squared theta actually equals sine squared theta due to Pythagoras' theorem, right? So you could even, write Pythagoras over here, okay? You could write multiply. Again, this is not 100% necessary. It's not necessary, but if you're, on a test or an assignment that you're handing in, you want to be clear as to what you're doing, so you might want to just jot something like this down. You can. And then once you get to this point here, you can kind of circle or square, and then QED is what I require to show me that you're done. And again, QED, quod erat demonstrandum, means that which was to be demonstrated. Yes, again, what this QED means is that you are done, it is proven, it is finished. Okay? Amen. Yeah. I'm sure Jesus said that on the cross. QED! Okay? It is finished. I don't know. Maybe. All right, next one. So with this one here, which one's the more complicated side? Yeah, over here. So you're going to want to do something with this side, okay? Is there an indicated operation? Well, there is a plus sign. Can we add those two together? Can I say this is 2 cos squared theta times tan squared? No, can't do that. You can't do that, right? Because these are unlike terms. That's one term, and this is another term. They are completely not the same. So, what else is jumping out at you there? Okay, tan can be sine over cos. All right, so let's go with that. Let's keep everything the same. No, that's okay. That's a good suggestion. Let's go with that. And we'll write this as sine squared over cos squared theta. Okay, that looks good. So if you choose to do that, now what jumps out at you? Yep, this right here, those are multiplied. And so cos squared goes with cos squared. And you've got cos squared theta plus, what's left over? Sine squared theta. And of course this is the Pythagorean identity. That equals 1. There's 1. QED, you're done. And that is great. Now that's not exactly what I was going to do, but that is a great way to do that. Can I show you now what I was thinking someone would notice first? I was thinking, and I will just do it down here, hopefully we'll be able to see both at the same time. I was thinking that, hey, there's a common factor of cos squared theta. Anyone else see that? A common factor that you can factor out. And so I was thinking this, cos squared theta, and this is going to be 1 plus tan squared theta. So I just saw that factor, the common factor first. Now you get to this point and you say, okay, what can I now transform? I can write cosine as 1 minus sine squared, or what's 1 plus tan squared? Was there anything that we saw in the identities? Let's zip way back here. Oh, those are double angles. Okay. Where is it? Ooh, 1 plus tan squared is secant squared theta. So that's one of the forms of the Pythagorean identity. And so this is cos squared theta, and now this is secant squared theta. Does that help us? Well, remember, we're trying to prove that this is actually 1. Okay, cos squared theta, and this is 1 over cos squared theta, isn't it? So that now equals 1. Now you're free to say multiply these together, it's 1. Okay? So that's another way you could do it, and same question. There's multiple paths here to the proof, okay? So, any questions about that one? Alright. This is pretty straightforward so far? Let's do another one. Alright, so here's another one. And again, the more complicated side, probably the left side here, I would say. Right? There's a little bit more to it, right? It looks like up here, this is a difference of squares, actually. Tan squared can be rewritten in terms of sine and cos. So you have two options there. This one over here, secant squared, 1 over cos squared. I don't know if that plus 1. I don't know if that really helps us. So why don't we go over here? We have two options here that stand out to me. So do you see that this is a perfect or a difference of squares? Okay. So when you factor that, what do you get? Yep. Awesome. Very good. That's what you get. And then over tan squared. Okay. Now, what did we just do in the last question? Anything that jumps out at you here? What was that identity we just used over here? 1 plus tan squared equals secant squared. Now, do we see that anywhere? 1 plus tan squared equals secant squared? Close, right? Close. 1 plus, well, okay, so 1 plus tan squared equals secant squared. So how can we, if we know that this is true, remember, you can rearrange these because they're identities already. So can I do this? Tan squared theta equals actually secant squared theta minus 1. Can I do that? Totally good. That is a form of the Pythagorean identity. So if we keep this in mind right here, then that means that this puppy right here is the same as this. So how could I communicate that? I don't want to just write secant squared theta plus 1 at this point. Okay, don't want to do that. Again, if writing a test, you want to show me that, hey, this is going to turn into tan squared theta. Okay, so just be clear. It takes you, 4.5 seconds here to write this out. Then you can go, that goes with that. Does this make sense? This actually goes down to secant squared theta plus 1. And what did I want to go to? Oh, that's what I wanted to go to. So look at that. Now you can say this side actually boils right down to this, the same as the other side. Quod erat demonstrandum. It is proven. It is finished. As the veil tears in two. Okay? Now, is there another way you could do that? Probably. Okay? If you want to rewrite all this in terms of sine and cos, if you're stuck, that works too. That's going to be a little bit longer to do this, right? This is, right, 1 over cos, right, to the 4th, minus 1. This is sine squared over cos squared. Flip and multiply. It's going to be a few extra steps, but you can do that too. All right, next one. All right, so here's another one. I'm trying to prove this left side is the same as the right side, right? So again, more complicated side, which one you want to work on? Probably this one. It's got an indicated operation. It's got tan. We can write them in terms of sine and cos. This one over here, we could rewrite secant squared as something else. Cosecant 1 over sine. You choose. You choose. But I would probably choose this one. Why? Because it's got an indicated operation like this. It's got tan. We've already got cos. This one to me is there's more options here to transform this. So you could do one of a couple things. Jump out at me. What are some of the options here that we have? Okay, remember it's recognition. What are some of the options that you might want to consider? Go ahead. Okay, question? Into sine over cos. And you can divide out common factors. What you can't do is this. You cannot do tan and tan. You can't do that because they're not factors, they're added. Right? So we can't do that. But you're on the right track. That's a valid idea. So let's write secant as 1 over cos. And let's write tan as sine over cos. Don't forget your thetas. Sin and cos by themselves make no sense. Can't do that. Over here now, you might want to do the same thing. Do sine theta over cos theta, and then over cos theta. Okay. So basically what you've done is rewritten everything in terms of sine and cos. That's one of the tips. That's a great idea. Now, from this point, you have 1 over cos divided by sine over cos. And so, yeah, the coses are going to be able to be divided out. Okay, so I would suggest you show that plainly by showing this fact that you can flip and multiply this rational. Now, what about over here? This is sine theta over cos theta times 1 over cos theta. Right? If you have sine divided by cos and you divide that again by cos, that's going to be cos squared on the bottom. So this cos and this cos are gone. You're going to have 1 over sine here. And over here is going to be sine over cos squared theta. All right. Now, are we getting close to what we want to have happen over here? I have cosecant right here. That's cosecant. But I've still got this nasty plus here. Right? So I'm not super close. So what do you have to do next? And I'm going to have to move down here. All right. So what you can do is you could say, listen, we could get a common denominator and add these guys. Right? You could do that. You could change cos squared into 1 minus sine squared. I don't know, would that help? I don't know. Let's add them together to get to one term and see what happens. All right? Performing the indicated operation is always a good idea. All right, so that means I have 1 over sine theta, and I need a cos theta. So let's do that, which means I got to do this on top as well. Now this one over here, I have sine. Oh, I just said not to do that. And this is cos squared theta. Now I need a sine theta here, don't I? So that means I need to do this. Okay, getting a common denominator. Is everyone on board with that? So here I have, and you can go ahead and put the common denominator down there now. This is sine theta times cos squared theta. And up top we have cos squared theta plus sine squared theta. Everyone see that? This plus this. Okay, so now you look at that and you say, well, that's a big mess. But do you recognize an identity there? Yes, cos squared plus sine squared is 1. Very good. That's 1 over sine theta times cos squared theta. Now, are we getting close? We're getting very close now, aren't we? Let's see. Let's go back up here. And I'm going to just kind of bring that down. Copy that. Bring it back down over here. Here. Paste that. Okay, so secant squared theta. Okay, that's actually 1 over cos squared theta. Cosecant is 1 over sine. So do you see how this is actually 1 over sine times 1 over cos squared theta, which is cosecant theta times secant squared theta. Do you have to write these in proper order? No, it's multiplication. It's okay. It's okay. You can if you want, but you don't have to. So when you get to this point, it's like, hey, that is the same as that. Q, E, D. So there's a few more steps now involved in some of these, right? These ones are getting tricky. Okay, I'll just let you take a look at this one again. Let me know if you have any questions.